Alright, so I believe I'm recording. Let's take a look at this interval and set builder notation that we're doing on day 2. In the beginning here it's multiple choice just like the previous one was, but then later you have to produce your own answers. So here we see that we're given the graph of a number line. We're interested in the numbers that the real numbers that are between -10 and +1, excluding those endpoints. When you have a hollow dot, it's an open parenthesis. It's always a smaller value, comma, a larger value. And since both of those are hollow dots, both of those values are excluded. They are not part of this set. This is what we're looking for. And here it is in choice B. I would not have ever picked choice A because 1 is not smaller than -10. And I would never choose choice D because it breaks the definition, the convention that it's always a smaller number, comma, a larger number when you're writing these interval notations. So I'm getting B for choice 1. Let's take a look at 2. Now this time the notation has changed. Rather than presenting our answer in interval notation, we're presenting our answer in set builder notation. So in set builder notation, you're always going to have the braces, and in the beginning you're always going to have x and a vertical bar. So you say the set of all numbers x such that x is an element of the set of real numbers. And when we're in textbooks, they often will have a bold R for real numbers. We really can't make it that bold, or it's not convenient when you're taking notes with pen and pencil. So rather than writing an R, which we'll later see as the range of a value, or excuse me, of a relation or a function, we'll just put a double spline there to make it be the set of real numbers. And hopefully in the context you'll understand which notation to use. This time I'm interested in the set of numbers that are between 0 and 6. I'm going to write a compound inequality. X is always going to be in the middle for a compound inequality. I like to write it in the same way that I see it on a number line, with the smaller endpoint on the left, the larger endpoint on the right. My arrows always point together, and they always point to the smaller value. When it's a solid point, when you're including the endpoints, it has to be less than or equal to. That underlying that is the equality, and that's necessary for this. So that's what I'm looking for in this problem, and I see it right there in choice A. Choice C, you would never get me to choose choice C because the arrows are going in opposite directions. That's nonsense. And the same for D. The arrows are pointing in opposite directions within that compound inequality. So we would never have a graph that we would have C or D as an answer. It could be choice B if these were hollow points at the endpoints, if we were excluding those endpoints. If we look at number 3, again, it's set builder notation. So every time that they're asking me to use set builder notation, I have it memorized that it's going to be contained in braces. For us, it always starts out X. Now, later on, if you're taking some math class, I suppose it could be a different variable, but for us, it's typically X. I guess in rare occasions it could be Y, but it's either going to be X or Y for us. So X is an element of the set of real numbers, and now my restriction, and I close the brace. So now I write an inequality. Now, we've seen in interval notation that we write this as -infinity to +1. Set builder notation will never have infinity symbols in them, and in an inequality you'll never have infinity symbols. A will not. There's no graph that we could write that the answer would be choice A or choice B. I can eliminate those immediately. Now, what I'm interested in is the set of all real numbers X, such that X is less than or equal to +1. So there's my inequality that describes all of the numbers that are smaller than 1. I may have said -1. smaller than positive 1, including positive 1. That's what I'm looking for, and I see it in choice C. It is equivalent to write that if x is less than or equal to 1, that's saying that 1 is the largest of all of these values. But you can see that the arrow doesn't agree with the direction of my number line. This is okay. This would be counted as correct. I cannot count this incorrect. But if you're using your variable like this, then you can use the diagram, and the arrow will point in the same direction that's being shaded. But either one of these answers is acceptable. You can see here that the arrow is pointing now towards the 1. This would be the other side that's not shaded. So the answer to this is choice C. Again, they're asking, no, this is interval notation. So this is like day 1. We've got -5 is the smallest value. Our infinity our arrow is shaded. For interval notation, we will use positive and negative infinity. We will never have a bracket at positive or negative infinity. No way am I going to choose choice C for an answer ever. And now when I look to -5, since it's hollow there, I exclude it, and that's an open parenthesis as well. So that is choice D. Never would I choose B. It's always a smaller value, comma, a larger value. Hey, this is as big as it gets, positive infinity. That's not smaller than anything. I would never choose that as an answer. So some of these on these multiple choice I can eliminate before I even start the problem, before I look for what I believe the true answer to be. Again, we're doing an interval notation. So I have these two intervals. Now I need a union symbol because I have two separate, I have a break in the graph. Let's start on the left. I've got -12, and then I've got -1. At -12, I'm excluding it because it's hollow, so that's an open parenthesis. At -1, that's a solid dot there. I'm including it. And now since there's a break, I need a union. Now these endpoints are 3 and 5, and since they're both solid, neither one of these are hollow, it's a bracket on both ends. So this is the choice I'm looking for, which it appears to be right there in choice A. No way would I ever choose D because -1 is not less than -12. It always goes a smaller number, comma, a larger number. And yeah. B wouldn't make, I've got two intervals and stuff, so for this problem I wouldn't, but it is possible if this part were not part of the problem, and if we had, oh, look, it's saying that you shaded that middle part all the way out to 5. I see why I chose that. What if somebody misinterpreted it and thought that all of this was shaded? Well, then you would choose choice B, but it's not. So for 5, this is A. Let's move on. Interval notation. Interval notations, we will see infinity symbols. We will never see infinity symbols with brackets. I would never choose choice C as an answer. And choice A kind of doesn't make any sense. Here's the set of all real numbers, and there's a minus, like you're subtracting. Well, with sets, we don't have the typical addition and subtraction symbols. We have a union symbol that's OR, that you can kind of think of that as addition, and we have an intersection symbol that we read as and you can think of that as a sort, I guess, of grouping of subtraction. All right, so in interval notation, the arrow shaded on the left, that's a negative infinity. My other endpoint here is 0. It's got a hollow dot, so it's an open parenthesis. There's a break in the graph, so I need a union. That's a solid dot at 6, so I include it. To the right, the arrow is shaded. That's going off to positive infinity. That's what I'm looking for among the choices. Excuse me, and that looks to be choice B. In problem 7, this time it's set builder notation. In set builder notation, you will never see positive infinity or negative infinity in set builder notation, and you'll never see positive or negative infinity with inequalities. It doesn't. We say that it doesn't make sense to say that x is less than infinity, because you're less than or greater than or equal to a number, and infinity is not a number. It's just kind of an abstract idea, of the idea of going on forever to heading towards large values. All right, so the inequality that describes all numbers that are less than -4, we have x less than -4, and because it's a solid dot, it's less than or equal to. I need to have that underlined, and then a union. And now here, this compound inequality, I have two endpoints. See, I didn't have an endpoint with negative infinity. I'm never going to use it. But now I've got 0 and 6. I'm always going to write the x in between them. On the left, it's a hollow dot, so it'll be strictly less than. And here it's a solid dot. And it's always a smaller value. The arrows are always pointing to the smaller value. 0 is smaller than 6. And the arrows here in this compound inequality must point in the same direction. Now it's possible the other arrow, this compound inequality, its direction, you might have, if you were shading to the right of something over here, you might have that arrow heading in another, not pointing in the same direction as these two, but within the compound inequality. Now, because it was set builder, I know that set builder is always going to have the brace, the x, such that x is an element of the set of real numbers, comma, and then close the brace. The part here with the inequalities I have to get from the graph. This is what I'm looking for among my choices. No way would I ever choose choice B. The arrows are pointing in opposite directions. There it is in choice C. I've got 0, strictly less than x, less than or equal to 6. This is the one that I want in C. Again, this is set builder notation. And within a set builder notation, within the inequalities, we're not going to have positive or negative infinity. No way would I choose choice A. No way would I choose choice B. All right, so let's take a look then and see if we can. We've got 3 intervals here. Of course, with set builder notation, I've got this part memorized, that it's the set of all numbers x such that x is an element of the set of real numbers. And now on the left here, I need to describe that interval. Well, I'm not going to use negative infinity there. What I am going to say is that all of these values that are in the shaded region right here are less than or equal to, because that's a solid dot, -7. And since I have a break in the graph, I have a union. And now with these two endpoints, I have a compound inequality. I've got the smaller value on the left. I've got the larger value on the right. I've got the variable in the middle. The arrows, the way I've written it, since I'm copying it directly from the number line, are pointing to the left. Here, since that's hollow, I'm going to leave that as strictly less than. But since +4 is a solid dot there, I include 4 in my set, and I have to underline that. Then I have a break to describe this interval. These values of x are strictly bigger than 7. It's not greater than or equal to, because that's not a solid dot. It has to be x greater than 7. So with these breaks, I needed the unions. Here you can see that within this compound inequality, the arrows are pointing in the same direction. Now this other inequality, separate from it, because it's the union that describes this other interval, it's okay that this arrow is pointing in the other direction. What's not okay is if you had the arrows here pointing in opposite directions. That's nonsense. You would never have that as an answer. All right, so let's look and see if we can choose this choice. X less than or equal to -7 union. Now here it's not B because I need it to be strictly less than. So let's look and see. I've got I don't see it. Do you? Okay, so I'm going to pick none of these. This D had this been underlined right there, then it would be D. But look, just that little detail right there makes me recognize that it's not D, because this would have to be hollow there, and it's not, or at least not on this version that I have that I'm doing. Sometimes I've edited these, so double check on your paper and make sure that that's solid there. Oops, I lost my negative symbol right there. So this is my answer, which is none of those choices. All right, now here I don't have any multiple choice, and they're wanting me to describe this set using interval notation and also set builder notation. So in interval notation, I've got -5, the smaller value, comma 2, the other endpoint. Since those are both hollow, these are open parentheses. Since there's a break in the graph, I have a union, and now I have endpoints of 5 and 9. 5 is smaller than 9, and since these are solid, I use square brackets there. That's my answer for the interval notation that goes up there. There's just not a lot of room there. So this guy is this answer. Now, for this answer, let's come down. We know that it says set builder, that we're going to have this brace. Your brace doesn't have to be look perfect. You can look on the keyboard. There is a brace there. If it's squiggly line, hey, that's going to be fine for me for now. But eventually, you'll have to be able to make those look pretty decent. Not when I say eventually, maybe not in this class, but in a future class. So for set builder notation, I know that this part is always going to be my answer. Now, I look to the graph here, and the constraint, how I describe this shaded regions, that's when I use the inequalities, and that could differ from problem to problem. So here I have two endpoints, so I'm going to write the smaller endpoint first, the bigger endpoint to the right. I have my variable in the middle. Since -5 is smaller than +2, my arrows are both pointing in the same direction, and they're pointing to the smaller value. -5 is smaller than 2. And since these are both hollow dots, I'm not going to underline both of those. That would be if those were solid. So I'm going to leave it exactly like that. Now, since I have another interval to write, I need that union symbol. And I'm going to try to do the same idea here. I have two endpoints. See, I don't have my arrow shaded. I've got endpoints. +5 is smaller than 9. My variable's in the middle, and 5 is less than 9. And this time, because both of those are included, both of those are solid dots, it needs to be less than or equal to. Less than or equal to. So this describes the same set of numbers that my interval notation did. Both of these say the same thing. That picture illustrates what both of these notations, the set of numbers that they're describing. All right, so for my interval notation, I've got a smaller number, comma, a larger number. Since those are both hollow, I use open parentheses. I'm done with the interval notation. For the set builder notation, I know that this part of it is always the same for all set builder notation. Now inside here, I need to describe what's shaded. Since I have endpoints, I'm going to write -1 and 6. I'm going to write the variable in the middle. I've got -1 is smaller than +6, so the arrows are pointing to the left. And since these are both hollows, I do not underline these inequalities. It is strictly less than. So this is the way to describe this graph using interval notation. This is the way to describe that same graph using set builder notation. In interval notation here, I've got infinity in here. In interval notation, we will have infinity symbols sometimes. So I've got -2, comma, infinity. I'm excluding -2, so that's an open parenthesis. And I always, infinity is not a number, so I'll never have a bracket there. Now, for set builder notation, this part I have memorized. It's always part of my answer. And now I need to use inequalities to describe what's shaded. I will never see an infinity symbol inside the set builder notation. I will never use an inequality that has an infinity symbol. So I've got my variable, and all of these values here are bigger than -2. And I do not underline it because that's not solid. Had that been a solid point, I'd say that they are greater than or equal to -2. These numbers are all just real numbers that are strictly bigger to the right of -2. So two different ways, two different notations to describe the same set of numbers. All right, so in interval notation, I've got negative infinity here. I've got positive infinity there. On the left here, I've got negative infinity. I'm going to -4. It's a solid point, so I need a bracket. There's a break in the graph. I need a union. And then it's 6 all the way out to positive infinity. Since that's hollow, I need an open parenthesis, and I never have a bracket around either one of the negative or positive infinities. There's my answer for interval notation. For set builder notation, I have the set of all x, real numbers, the set of all numbers x, such that x is an element of the set of real numbers. And this left interval that's shaded here, I'm not going to use negative infinity in my inequality. I'll never see positive or negative infinity in the set builder. All these numbers are smaller, less than -4. So I've got an inequality, the x, and because it's a solid dot, less than or equal to -4. I have a break. I need to describe a separate interval, so I have a union. This time, all of these values are strictly bigger than 6, and x is strictly larger than 6. X is any one of these values. The arrow always points to the smaller value. 6 is smaller than any of the values in the shaded region. Don't forget to put your brace there to close your set. All right, so two different notations that describe the same set of numbers. In number 5, in interval notation, I have this interval where I have endpoints of -1 and +3. Smaller number, comma, the larger number. -1 is excluded. That's an open parenthesis. +3 with a dot there is included. I have a break. I have a separate interval, so I need a union symbol. And now here's 7, and it's going out. This arrow is infinity. It's okay for infinities to be part of my interval notation. They'll never have a bracket. For set builder notation, I always have the set of all numbers x, such that x is an element of the set of real numbers. Now here, since I have two endpoints, I write the endpoints down and the variables in the middle, and I make that since -1 is smaller than +3, the arrows both point in the same direction always, and they always point to the smaller value. -1 is excluded, so I do not underline that. +3 here is included with that solid dot, so I need to have that be less than or equal to. I have another interval to describe, so I need a union symbol. I will not use infinities and inequalities. I've got a 7 here. All of the numbers are to the right of 7. All of these values x are bigger than, and since it's a solid dot, they are bigger than or equal to 7. So here is two different notations that describe the same set of numbers. This is referred to as interval notation. This is referred to as set builder notation. For interval notation, I've got my arrow shaded here. I have the arrow shaded over here. Those are my infinity symbols. I have a hole in the graph. So I've got two separate intervals to describe. So from negative infinity up to -2, excluding negative, that's not a solid dot, so I need an open parenthesis. So you're on this left interval, or I need a union symbol. You're a number that's bigger than -2, so I can't include -2 all the way out to positive infinity. So this is the set of all real numbers excluding -2. Now, that's the way that we write it using interval notation. With set builder notation, I actually have two ways that I can write my answer for set builder notation that is commonly accepted. I've got x, the set of all numbers x such that x is an element of the set of real numbers. Now, I can describe this left interval as all numbers x that are strictly less than -2. There's a hole in the graph, so then there's a separate interval, so I need a union symbol. All values of x, all real numbers that are strictly greater than -2. So look at the picture. This is saying the number, you're either smaller than -2 or you're bigger than -2. Pick any number you want that's smaller than -2 or bigger than -2. Now, in set builder notation, you'll also see people write that x is an element of the set of real numbers, and rather than writing it like this, they'll just say it's all real numbers except that x can't equal -2. So sometimes students prefer that. So all three of these are notations that describe the same set of numbers. These last two are set builder, and in set builder, both of those are acceptable notation to describe this set of numbers. Here we have the set of all real numbers. The entire number line is shaded. Using interval notation, that is from -infinity to positive infinity. So we write -infinity and positive infinity. We cannot have square brackets, and we must have the open parentheses. You can't leave one of those off. You'll lose points. It has to have the parentheses there. For set builder notation, this one's so easy that it's hard. Typically, we write an inequality that describes this. Well, this is just all real numbers. So you don't have any constraint. So you can just write your set builder notation like this. It's the set of all numbers x such that x is an element of the set of real numbers. Well, if somebody says, well, which real numbers are you talking about? You go, any of them. Pick anything you want. From any number at all, as long as it's a real number, not complex numbers. This two different ways, two different notations to describe the set of all real numbers. All right, so in interval notation, I've got my arrow shaded, so that's -infinity. I'm coming here, my big endpoint. Here, I'm going to have to eyeball it. So let's just call this 3.5. If you want to call it 3.4, I'm not going to argue. Since this is an arrow, I never have a bracket. Since that's open, that's an open parentheses. So like I say, I just estimate. There's no way for me to give a decent estimate. Somebody else might jokingly say, hey, that's 3.49. I can't argue with that, So here's my best guess as to what that is, 3.5. Now, in set builder notation, I have embraces. I have x such that x is an element of the set of real numbers. To describe this, I do not use this -infinity symbol. I just use my variable x and say that it is strictly less than. And again, I just have to eyeball it. Now, since I went ahead and called it 3.5, I'm not going to change it and call it some other number now. So I am going to try to have some consistency within my two answers, because both of these are describing the same set of numbers. So here's my answer for interval notation, and here is my answer for set builder notation. In interval notation, I can use positive and negative infinities. I've got my negative infinity here on this interval. The endpoint is positive 2. I'll never include positive or negative infinity. That's always going to be an open parenthesis. But here, since 2 is solid, I need a bracket. Then I have a break in the graph as second interval. So I have or the union with this other interval that has an endpoint of 3. And this arrow is shaded. It's going out to positive infinity. This is a hollow dot, so I am going to exclude the number. The number 3 is not part of the shaded region. It is not in my set of interest. And infinity is not a number, so I can't include it in my set, so I need an open parenthesis there. To describe the same set of numbers using set builder notation, I have the set of all numbers x, such that x is an element of the set of real numbers. To describe this interval on the left, I do not use positive or negative infinity when I'm using inequalities. So I say that this is less than 2, but since it's a solid dot, I actually say that these numbers are all less than or equal to positive 2. Or I've got 3 here. I don't have another endpoint that's infinity. I'm not going to use it. Or I've got x is to the right of 3. X is bigger than 3. X is strictly bigger than 3 because it's a hollow dot. So that these two, this is the interval notation way to describe this set of numbers. This is a set builder notation way to describe these set of numbers. All right, so here I've got endpoints in interval notation. It's always a smaller number, comma, a larger number. On the left, I'm excluding negative 4 is not part of this shaded region. It's not in my set of interest, but positive 4 is, so I put a bracket. In set builder notation, I have this part of these symbols memorized. And now, since this is has both two endpoints, I put the smaller endpoint here, the larger endpoint here, the variable in the middle. I have the arrows pointing to the smaller value. Negative 4 is smaller than positive 4. Both arrows are always pointing in the same direction. On the left, that's hollow, so I leave it strictly less than. And on the right, it's solid, so I need that. Don't forget to close your brace. Both of these are two different notations that describe the same set of numbers. So here I have both of my arrows shaded. So in interval notation, I will be using those infinity symbols, but in set builder notation, I will not ever use infinity symbols. So here this is negative infinity. Negative infinity is the small as it gets, comma, a larger number, which is negative 6. I never include positive or negative infinity. Since that's hollow, I do not include negative 6. So the number of interest is in this interval, or it's in this interval that it's bigger than 2. Excuse me. 2 all the way out to positive infinity. Since that's a solid dot, I need a bracket and a parenthesis here. I have to pause this for just a second, get a drink of water. I'll be right back. All right, so hey, I'm back. Probably didn't feel like I was gone no time at all. All right, the set builder notation. The set of x such that x is an element of the set of real numbers. This left interval are all values of x that are strictly less than negative 6. I will never have positive or negative infinity symbols in an inequality statement, since I just have that interval, or I have values of x that are bigger than positive 2, and I want to include 2 in this set of numbers, so greater than or equal to. Two different notations that describe the same set of numbers. The first notation is interval notation. The second notation is set builder notation. Here in number 12, I've got negative infinity, I've got 2 in interval notation, smaller comma a larger value. You never include positive or negative infinity. 2 is included because it's a solid dot. 2 is a member of this set of interest. That is the way to describe this infinite set of numbers that's shaded using interval notation. Here's the interval. It chopped off the word interval. Set builder, I know it always starts the same way. It has these symbols. I have the set of all numbers x such that x is an element of the set of real numbers, meaning that it belongs to that set, that it's a member of the set of real numbers. And here, this x, all of these values are less than 2. And in fact, we're going to include 2, so it's less than or equal to 2. So that's how I describe that set of numbers. So 2 different notations that describe the same set of numbers. This is referred to as interval notation. This is set builder notation. All right. Here in interval notation, I almost thought that was an arrow. Don't go so fast that you look to make sure whether it's a solid dot or an arrow. Here it's a solid dot, so it's -10 all the way to -7. I exclude -7, or I'm in this interval that has endpoints -4 and +6. I'm excluding -4. I'm including +6. That is how I describe that set of numbers using interval notation. For set builder notation, the set of all numbers x such that x is an element of the set of real numbers. On the left here, I have 2 endpoints. I like to write the smaller number, then the larger number, put the variable in the middle, have the arrows pointing to the left. Here, it's less than or equal to because it's a solid dot. Here it's a hollow, so it's strictly less than. Or I'm in this interval, which has endpoints of -4 and +6. The variable x is in the middle. The arrows point to the smaller value. -10 was smaller than -7. -4 is smaller than +6. When I'm saying point in the same direction, it's just within that compound inequality. After the union, this pair has to point in the same direction. Now, since 6 is included, I have to have less than or equal to. So, 2 different notations that describe the same set of numbers. This is interval notation. This is set builder notation. Hopefully that helps. Talk to you later.